Today we will discuss about the extrema of functions of two variables. Functions of two variables. Okay, so we have to check that how to calculate or say that the function have the maximum value or minimum value. So we have some working procedure for finding the extremum value of the function. So first we start. We have a function fxy. So we find out del f upon del x means first derivative, del f upon del x, del f upon del y, and put del f upon del x is equal to 0, del f upon del y equal to 0 for finding the stationary value. Finding the stationary value or stationary points. So the points or the value are A and B. So then we obtain second derivatives. So means del square f upon del x square. So this second derivative with respect to x we denote it as r. Del square f upon del x del y we denote it as s. Del square f upon del y square denoted by t. So we obtain the second derivative r, s and t. First derivative we have that means del f upon del x which is denoted as p and del f upon del y denoted as q. Now we follow some conditions. So we have first condition is that means if the value of rt minus s square which is greater than 0. So rt minus s square gives us the positive value and the first point r is less than 0. So then the function fxy has the maximum value. Second, r greater than 0. So we say that then the function fxy has a minimum value. And second condition, we have if rt minus s square is less than 0, so then the function fxy has no extreme value. At the point AB. So we are calculating all these things for the values AB. Okay. So for third one, if RT minus S square is equal to 0, so such type of cases are doubtful cases. So then the case is doubtful. We need further. Okay, so this is the procedure we have to remember. That means we calculate the first derivative with respect to x and y, and second derivative with respect to x and y. So we denote it as first derivative as del f upon del x and del f upon del y, and second derivative del square f upon del x square, del square f upon del x del y, and del square f upon del y. Now we take some problems related to that. So question is, find the maximum and minimum of the function. Function is given as f of xy. F of xy is equal to x square plus y square plus 6x plus 12. Okay, so function fxy is given as x square plus y square plus 6x plus 12. Now when we do the solution, so first we obtain the first derivative. So we write down the differentiate partially with respect to x and y. So we write down as del f upon del x. Del f upon del x gives us 2x plus 6, and del f upon del y gives us 2y. Okay, so these are the first derivative. When put del f upon del x is equal to 0 is equal to del f upon del y for finding the stationary value. So we see that. So first equation is 2x plus 6 equal to 0. So this we can write down as x plus 3 equal to 0. So this gives us x equal to minus 3. So x equal to minus 3. From second equation, we write down as 2y equal to 0. This gives us y equal to 0. So the stationary point we write down in the form of order pair. So the stationary value is minus 3 comma 0 is the stationary values or stationary point. Okay, so this is our stationary point. Now we obtain del is second derivative del square f upon del x square. So del square f upon del x square. So we have del f upon del x equal to 2x plus 6. So del square f upon del x square equal to 2. 6 is the constant. Differentiation of constant is 0. Again, we calculate del square f upon del x into del y. So this can be calculated as del upon del x into del f upon del y is equal to del upon del x into del f upon del y. What is the value of del f upon del y? The value of del f upon del y is 2y. So when we differentiate this with respect to x, so gives us 0, because when we differentiate partially with respect to x, treat y as a constant. लास्ट हम कैलकुलेट करेंगे डेल स्क्वायर एफ अपॉन डेल वाई स्क्वायर. तो डेल स्क्वायर एफ अपॉन डेल स्क्वायर एफ अपॉन डेल वाई स्क्वायर इज 2. Okay, so we have del f upon del y equal to 2y, so del square f upon del y square equal to 2. Now we have all values. So this del square f upon del x square we write down as r. This value we write down as s, and this we can write down as t. So we have all three values r, s, and t. So we follow the conditions. That means the condition is that rt minus s square. So first we obtain rt minus s square. So r equal to 2, and we apply the stationary point of all the values of r, s, and t. So we see that so all value r, s, and t are constants. Okay, r, s, and t are constants. So that means r t minus s square. S square means 0. 0 to the square. So this gives us 4 minus 0 is equal to 4. Okay, so we write down as at minus 3 comma 0. So rt minus s square, that gives us the positive value. Positive value means greater than 0. And we see that r. What is R? R is equal to 2. So 2 means greater than 0. So when R is greater than 0, so we have the first condition. First condition is that when we have R less than 0, function have the maximum value. When R greater than 0, function have the minimum value. So here we have R greater than 0, the function have the minimum value. So hence the function xy has the minimum value. Function fxy has the minimum value. And what is the minimum value? So we also calculate minimum value of the function. So the minimum value of the function, we calculate the minimum value of the function. So f of xy, so x equal to -3, y equal to 0. So this gives us -3 to the square plus 0 to the square plus 6x or plus 12. So we write down as -3 to the square is 9, 9 plus 0, 0 minus 18, 18 plus 12. So this gives us 3. So minimum value of the function is 3. Okay. So similarly, we take another question related to that. Next question is that examine f of xy is equal to x cube plus y cube minus 3axy for maximum or minimum values. For maximum or minimum values. So when we do the solutions of function given as fxy equal to x cube plus y cube minus 3axy. So first we calculate del f upon del x. So differentiate with respect to x. So del f upon del x gives us 3x square minus 3ay. Next derivative, del f upon del y gives us 3y square minus 3ax. Okay. Similarly, we calculate second derivative. Del square f upon del x square gives us 6x. Del square f upon del x del y gives us del upon del x into del f upon del y is equal to del upon del x into del f upon del y 3y square minus 3ax. So this gives us minus 3a. Gives us minus 3a. And del square f upon del y square is equal to, so when we differentiate this with respect to y, gives us 6y. So these are the values. So first value we can write down this as r, this is the s, and this is the t. Now first we calculate the stationary values. So for calculating stationary value, for calculating stationary value, we put del f upon del x is equal to 0 is equal to del f upon del y. So when we put del f upon del x is equal to 0, so we see that first equation, that means we write down as 3x square minus 3ay equal to 0. So this gives us x square minus ay equal to 0. So we can write down this as x square is equal to ay. And when we calculate the value of y, so this can be written as x square upon a. From second equation, that means when we put a del f upon del y equal to 0, so this gives us 3y square minus 3ax equal to 0. So when we divide by 3, so y square minus ax equal to 0. So y square is equal to ax. So when we put the value of y in equation 2, so that means in this equation, so we write down, put the value of y in above equation. So we see that y means x square upon a to the whole square is equal to ax. So this gives us x raised to the power 4 upon a square is equal to ax. So when we write down this as, so this can be written as x raised to the power 4 equal to aq into x. So when we take x as a common, so this gives us x into x cube minus a cube is equal to 0. Now we factorize this. A cube minus b cube का फॉर्मूला तो आपको आता ही होगा. So x into x minus a minus b, and a square plus ab plus b square is equal to 0. So यहाँ से हम देखते हैं थर्ड फैक्टर. So this have the all positive signs. So that means the roots will be the imaginary. Okay, there is no real roots. So now we find the roots from first and second. So the root from first and second, this gives us x equal to 0 and x equal to a. Okay. So when we have x equal to 0, x equal to a, so these value of x equal to 0 and x equal to a put into the above equations. So we have the value of y. We have y is equal to x square upon a. So in this value put x equal to 0. So when we put x equal to 0, so this gives us y equal to 0. Put x is equal to a, gives us y equal to a square upon a is equal to a. Okay. So the stationary values are, stationary values are 0 comma 0, x equal to 0, the y equal to 0, or x equal to a, then y equal to a. So we have two stationary values. On the basis of these two stationary values, we obtain the maximum or minimum for both. Now, we construct a table for writing the values. So here we write the first stationary point, that is 0, 0. Now we write the second stationary point, that is a. Here we write the value of r, we write the value of s, and we write the value of t. So r, s, and t. So we have the value of r. The value of r is 6x. Value of s is minus 3a. R having the value 6x. This having minus 3a. And t also having minus 6 plus 6y. T also having values plus 6y. Now, when we apply the first stationary value on the value of r, s, and t, so when we put x equal to 0, okay, x equal to 0, so 6 into 0, 0. So the value of r is 0. And when we put the value of x and y in s, so this is purely constant, gives us minus 3a. When we put a y x equal to 0, y equal to 0 in t, so it gives us 0. Now, similarly, we write down for AA. So 6a, this is constant, so write down the same. This is also 6a. Now, we check RT minus S square for this stationary point. So RT minus S square, this gives us R into T, 0 into 0 minus 3a square. So this gives us minus 9a square. So minus 9a square, obviously always less than 0 because we are doing a square. So always 0, so which is less than 0. So RT minus S square is less than 0. So in this case, we have no extreme value. So for this one, we have no extreme value. Similarly, we have to check RT minus S square. So this gives us R 6a and T also 6a minus S square to minus 3a square. So 6 means 36a square or minus 9a square. So this gives us 27a square. When we put the value of any value of a, so gives us a square means positive. Positive means 27a square is always greater than 0. So for this, no extreme value, no extreme value at origin 0, 0. Or this has the extreme value. This has the extreme value. But we have to check the extreme value. That means the value of R. So what is the value of R here? The value of R is 6a. So the value of R is 6a. Okay, so 6a, that means we consider as positive. So we see that AA has the minimum value. AA has the minimum value, and the minimum value of the function we calculate the minimum value of the function. So this equal to FAA is equal to AQ plus BQ minus 3AXY. So 2AQ minus 3AQ. So it gives us minus AQ.